This is day 30 of my 6-mark challenge for AQA GCSE Science. Each day in the run-up to the exams from Monday to Saturday, I'm posting a new 6-mark question so that you can test how your revision is going. You'll find a link in the description below to all of this week's questions and also all 30 of the videos so far. Today's question is about one of the physics required practicals. Now, before you launch into writing an answer, don't forget, this is not an essay question, even if they give you a whole sheet of A4 to fill. So rather than answering in full sentences, I would suggest that you structure your answer in the form of bullet points, or maybe a numbered list, or even a table, although probably not for this type of question. Also, really make sure that you are answering the full question. Now, if you haven't done so already, pause the video and give yourself 6 minutes to answer this 6-mark question. This question is a bit of a funny one because there are actually 4 different routes you could take to getting the full 6 marks. You could measure all 3 of these quantities, but since they're all interconnected, if you know the formula that connects them, then as long as you've measured 2, you can calculate the third mathematically. So I could measure wavelength and frequency and then use those to calculate velocity. Or I could measure wavelength and velocity and use that to calculate frequency. Or I could measure frequency and velocity and use that to calculate wavelength. So really there are 4 different approaches that I could be taking here. The first thing I'm going to do is to write down the equation that interconnects these 3 quantities. So wave speed or velocity is frequency multiplied by wavelength. And then I'm going to point out that in order to do this practical, I'm going to need a wave tank. So a big tank of water with some kind of oscillating bar that produces the waves. Then if I start off by thinking about how to measure the wavelength, this is physically a length. So my first step is going to be to place a meter ruler alongside this wave tank or ripple tank. And then rather than trying to do this in real time, which would be really challenging, what I'm actually going to do is take a photograph of my ripple tank. And I'm going to be able to see where the wave peaks are because there's physically more water in those wave peaks compared to the wave troughs. And so less light gets through and therefore they look darker and you see these dark stripes and you can see that really clearly on a photograph. So my photograph needs to take into account the ripple tank and also the ruler that is alongside it. And then I'm going to literally physically measure the length of a wave. And in order to be as accurate as possible, I don't want to measure just one wave, I want to measure multiple waves. So 10 is usually a good number to go for. Then once I know what the distance is for those 10 waves, I can divide by 10 in order to find one wavelength. So if, for instance, it's 22 centimetres for 10 waves, then one wavelength would be 2.2 centimetres. And then I would probably convert that into metres because if I'm going to go on and use this calculation later, of course, my wavelength does need to be in metres. Then for frequency, assuming that I'm using an oscillator to produce these waves, I can probably just read the frequency off it. But I'd be wary of saying that in an exam, even though they have given credit for it in the past. So instead, I would probably describe identifying a particular point and counting how many waves go past that point. Now, of course, frequency is how many waves pass the point per second, but I'm not going to measure the number of waves per second because that's probably not going to be very accurate. I might end up thinking that there are 2 waves passing a point per second. But actually, if I waited for 10 seconds, I'd probably find that actually I saw 21 or 22 waves. So by waiting for a longer period of time, you can have a better, more accurate idea of what the period of the wave is. So you're going to divide by the time in order to get the frequency for just a single second, and that will give you your answer in hertz. And then if you've calculated or measured those 2 initial quantities, you don't actually need to measure velocity because you can work it out. But just in case you went for measuring velocity and doing things the other way around, the way that we would do this is again to place that meter ruler alongside the ripple tank and then measure the time that it takes for one wave to travel either the length of the tank, or you might pick a slightly smaller length if the tank is a weird length. Say if it was 24 centimetres, it might just be easier to see how long does it take for a wave to go 20 centimetres. And of course, to do that, you're going to need a stop clock. Then we can use the equation that velocity is the distance divided by the time in order to work out the velocity of that one wave. Having done all of that measuring, we then want to go back to that calculation and say, okay, so now I'm going to use this equation and these two pieces of information that I've measured in order to calculate the third piece of information. In order to get 6 marks in this question, you're going to need to explicitly say how you would identify all 3 pieces of information. So either measuring all 3 or measuring 2, and then saying that you're going to calculate the third and giving them the equation that you would use in this instance. That's it for week 6 of my AQA GCSE Science 6-mark challenge. I'll be back again on Monday with a new biology question, and I hope to see you then. Don't forget, you can find a link in the description below to all of this week's questions and also the playlist with all 30 videos so far. Thank you very much for watching, and I hope you're enjoying my GCSE Science 6-mark challenge. If you have found this video useful, then don't forget to like and subscribe for more GCSE Science revision resources coming soon.